What up, YouTube? It's Mr. T, and Mr. T do numbers with another video. This time we're gonna get into the base 10 system. All right. This is normally one of the first lessons I teach to my 5th graders because they have to understand place value. All right. So the base 10 system describes our numbering system. Right. Most people don't realize that our numbering system only has 10 numbers. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And on 0 through 9, that's only 10 numbers, right? What changes to make bigger numbers is you're moving them in different place value spots. But in actuality, we have a base 10 system, which means that we only have 10 numbers in our system. But the biggest number that can go in each place value spot is 9. Once you get to 10, that spot becomes 0 again, and you move the 1 to the left to start a new place value spot to the left. That's our base 10 system. There's only 10 numbers in the system, right? And most people, oh, Mr. Dre, we got an infinity, right? No, in actuality, there's only 10 numbers in our system. What you're doing is just changing the spots that you put those 10 numbers in. And it makes it seem like you have a bigger number. But the truth is, there's only 10 numbers in our numbers. I know what the kids is like. It's like mind blowing to them. They are we only have 10 numbers? Yes, you only have 10 numbers in the system. All right? And I can prove it to you. All right? So, I always start off with place value, right? The simple place value. And in 5th grade, you have decimals up into the thousands place, right? So I always start off with a simple place value chart, right? You got your ones place. You got your tenths, TN, THS. Not to be confused with the tenths that go over here, but tenths, right? You have your hundredths. Not to be confused with the hundreds that go 2 places up here. And you have your thousandths. Right? So I always start off with a simple place value chart. Right? To prove the base 10 system. Now, the first thing I tell you, my students, is the decimal point separates the whole numbers on the left from the parts on the right, right? So if you're on the left side of the decimal point, you are a whole number position. 1 wholes, 10 wholes, 100 wholes, 1,000 wholes, right? Those are whole numbers going to the left. On the right, these are parts. And all of them end in THS, which signifies the parts. And I tell my students that THS means parts, so the word in front of THS tells how many parts you need to make a whole in that place value spot. So tenths means 10 parts, which is why it's closest to the 1 whole spot, because you only need 10 parts in this spot. Once you get to 10 parts, you have a whole. What does that mean, Mr. Trahan? 1 tenth, 2 tenths, 3 tenths, 4 tenths, 5 tenths, 6 tenths, 7 tenths, 8 tenths, 9 tenths. That's 0.9, right? When you get to 10 tenths, this becomes 0 again, and you move a 1 to the 1 whole spot, because it only takes 10 parts in this place value spot to become a whole. That's why this is the 10th spot. 10 parts make 1 whole. All right? Now this is hundredths, meaning 100 parts make a whole. And most people know this by cent. Pennies, right? Change when it comes to money, because it takes 100 cents to make a whole dollar, which means your money system is in hundredths, right? Think about it. 25 cents, 2 in the tenths, 5 in the hundredths, 25 cents. When you get to 99 cents, that's 0 and 99 cents. So if you add one more cent, now you have 100 cents. You have 100 parts. That makes a whole dollar, right? Because this becomes a 0, you move it right here. This becomes 10, you move it right here. That's a 0, and you put the 1 right there, right? So it takes 100 parts. If you're in the 100 spot, if you're moving all the way to the 100 spot, it takes 100 parts to make a whole, right? And this is the 1,000 spot. 1, 2, 3. So you could say 0 and 999 thousandths, right? Well, if you add one more thousandths, now you have 1,000 parts, which means you have a whole, because this becomes 0, 0, 0, and you put the 1 in the ones place. So remember, THS means parts. The word in front of THS means how many parts it takes to make a whole from this spot right here. All right, so that's just a simple definition real quick. All right, so I also teach with base 10 blocks, and I tell people in my class, those blocks don't have a certain number. I know when you were in elementary, when you were in 3rd grade, 2nd grade, 1st grade, they told you those blocks have a certain number, right? They told you the cube, that's 1,000. And they told you the flat, that's 100. They tell you the rods, or you call them skinnies, those are, or sticks, those are 10. And they tell you the unit, those are ones. But if you really understand the base 10 system, you'll realize that you can move those base 10 blocks in any position and the system still works. So I'm going to prove that right now. All right, so I always start off with a cube. All right, so I'll put a cube right here. I'll draw a square, and I'll put another square up like that. Then I'll connect them like this. All right, I have a simple cube. All right, then I'll say, okay, I want the cube to represent the ones place, right? So if the cube represents the ones place, and I take one whole cube and break it into 10 parts. Now think about having a 3D cube, and think about taking that cube, that big old block, and breaking off 10 parts. What happens is, now you have 10 flats. Right? So that means if the cube is worth one whole, and one whole cube broken into 10 parts creates flats. Right? Now if you take the cube and break it into 100 parts, you create rods. And if you take one whole cube and break it into 1,000 parts, this creates units. All right? Now, you know it makes sense because as you go to the left, you are breaking it down into denominations of 10. So this is the base 10 system. So the cube is 10 flats put together. So you take a flat and break it into 10 pieces, you have 10 rods. And you take a rod and break it into 10 pieces, you have 10 units, because it's the base 10 system. And you could go backwards. 10 units put together creates a rod, 10 rods creates a flat, 10 flats creates a cube. That's how you know that those are in the right spot according to the base 10 system. Right? So I also tell my kids, the system still works. You can interchange the blocks, right? Because they used to think the cube was 1,000 holes, right? Oh, that's 1,000. It's a base 10 block, which means you can plug it in anywhere in the system, and as long as you plug the smaller ones behind it in descending order, it's still the base 10 system. All right? So let's change it up. I'll give you another example. This time, I want the flat to represent one whole. All right, it's kind of crooked, forgive me. But let's say I want the flat to represent one whole. In this problem, the flats, or the fifth grade problem say, in this problem, a large square represents one whole, right? So now I have a flat as one whole. If I take one whole flat and break it into 10 parts, I have created rods. Right? And if I take one whole flat and break it into 100 parts, this now is units. Right? And you say, Mr. T, what go right here? Well, if I take this and break it into 10 of these, and I take one of these and break it into 10 of these, now I have to take one of these and break it into 10 pieces. So normally you'll see that unit, right? I'm gonna draw it a little big so I can partition it. And for the sake of imagination, let's say this was 10 pieces. So 1,000 would be one of these. So take a unit and break it into 10 pieces. All right? So this is if the flat is representing one whole. So if I put the flat in the one whole spot, 1/10 of a flat is taking a flat and breaking it into 10 parts. That's a rod. Taking a rod and breaking it down to units. Or saying if I take a flat and break it into 100 parts, that's a unit. So it makes sense if you understand the base 10 system, because 10 of these equal one of these, and 10 of these equals one of these, and 10 of these equals one of these, right? And in this instance, in the 10 whole place will be the cube, because take 10 flats and make one cube. So in 10 whole spot, it'll be the cube, all right? So all you have to understand is the base 10 system, and from there you can interchange things, right? I'll give you one last example. In 5th grade, you also have the rods. In this example, I want a rod to represent one whole, right? So there's a couple of problems on like star test, on snapshots, right? They'll say, I want the rod to represent one whole, right? You're like, what? Right? It's true. So if you take a rod and break it into 10 parts, this is units. All right? And then if you take a unit and break it into 10, or if you take a rod and break it into 100 parts, now you have what we have right here, taking a unit and breaking it into 10 pieces, right? And then shading one of them, right? It's rare, but you do see it, right? So again, this is all part of the base 10 system, which means when you get to 10 of these, you can trade it in for one bigger size. Or if you take the bigger size, you can trade it in for 10 smaller ones. All right? That's the base 10 system. All right? Now let's talk about money, right? Because some of y'all like, I don't understand how you changing these blocks, Mr. Traham. I don't understand. All right? So I bet you understand this. In the ones place, I have a $1 bill. One whole dollar. Right? Excuse the glare off my my light. Alright? So I have one whole dollar. So if I take a whole dollar and break it into 10 parts, that creates a coin, right? Because this is the whole side and these are parts of a whole. And parts of a whole is like change, because you need those parts to add up to a whole, right? So if I have a whole dollar, what is a whole dollar represented in 10 parts? Well, that's naturally a dime, which is 10 cents. All right? And what is a whole dollar breaking into 100 parts? Well, that's naturally a penny, because it takes 100 pennies to make a whole dollar. Right? Then what is a whole dollar broken into 1,000 parts? From here we use bits. right? If you know anything about Bitcoin, you'll realize that regular money stops in the hundreds place, but in Bitcoin, it gives you the capability, because it's digital, it gives you the capability to go past the hundreds place when you're talking about money, right? So if you want to go on to the thousands, whatever, we'll talk about bits, right? It's a term that I use for thousands place, all right? Now, the main thing that you realize is the base 10 system. I can make a 10 or I can break a 10. In all of these different examples, you're seeing the same thing. If you're going from a small size, you need 10 of them times 10 to get to this size, right? So it would take 10 bits or 10 thousands to get to the hundreds. Now from here, you take 10 hundredths to get to 1/10, right? Times 10. And then from here, you take 10 tenths to get to the ones, right? Times 10. And think about it. If this is a $1 bill, 1 times 10 will give me a $10 bill. And 10 $10 bills will give me a $100 bill, right? So you're making 10, or if you're going backwards, you're breaking a 10, right? So if you're going backwards, you would find a tenth of it, right? Because a dime is 1/10 of the dollar. Take the dime and break it into 1/10, and you'll get pennies. Take a penny and break it into 1/10, and you'll get bits, which is why they don't have that coin for a physical coin for bits in circulation with money right now. It would take 1,000 parts just to get a whole dollar. All right. So again, this is Mr. Traham. This is a simple lesson on just the base 10 system, right? Understanding that there's only 10 numbers in our numbering system. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, which means that in these place value spots, you only can go 0 through 9. Once you get to the number 10, this spot becomes 0 again, and you move the 1 to the left. And you keep doing it over and over. Times 10, you trade in for here. Times 10, you trade in for here. Times 10, you trade in here, and on and on and on. And then if you want to break down the 10, you're going backwards because you're taking 1/10 of the spot you just left. All right. So I hope you understand. Feel free to like, comment, share this video. Again, this is a simple lesson on the base 10 system. Peace.